An electrowetting display is a type of reflective displays which is based on the electrowetting effect. The display consists of two glass plates separated by gap elements. At the lower part of the plate, there is an aluminium film serving as a common electrode and as a reflector. On its inner surface, there is a matrix of cells, which are filled with an oily liquid. The surface of the cells is covered with a water-repellent layer. The liquid, interacting with the layer, tends to roll up in a drop. On the inner side of the upper plate, there are transparent control electrodes. The free space between the plates is filled with a thin layer of water. A coloring agent, which is added to the oily liquid, determines the color of the whole pixel. An image is formed by the means of changing the direct voltage applied to the upper and the lower electrodes. Optical properties of a cell depend on the ratio of the areas of the colored oil layers and water ones. In the absence of voltage, the oil film covers the entire area of the cell that corresponds to the mode off. At the same time, the major part of the light flux is retained by the coloring agent or the oil film, and it does not reach the observer's eye, what is perceived as a dark pixel. On the contrary, if the voltage is present, the oil film rolls up into a drop that corresponds to the mode on and is perceived as a light pixel. There is also an intermediate state which allows to regulate the brightness of each pixel. The main advantage of such displays is that in order to control the pixels, a low voltage is used, and the display itself has a very low power consumption. Thus, reflective displays, created on the basis of electrowetting effect, in many respects are far superior to similar constructions based on liquid crystal technologies.